So today I'm going to talk about pentaborane 9 as a rocket or hypersonic missile fuel. Unfortunately, pentaborane 9 cannot be used in a jet engine where you have turbine blades because the turbine blades will be eroded by the film and particles of solid boron released from oxidation from combustion. So the solid particles will erode the turbine blades, and when this fuel was studied in the 1960s as a way to enhance aircraft range, it was found that it was inoperable in turbines. So really the only thing you can use it for is in a rocket engine or a ramjet. And so hypersonic missiles, I think, are most attractive for pentaborane 9. But it can also be used along with an oxidizer as a rocket fuel. And the ideal oxidizer is dioxide to fluoride, to fluoride. And apparently, from what I've heard, the specific impulse of that combination of that fuel combo would be over 500 seconds. So that's significantly higher than LH2, is significantly higher than UDMH N204, which is the standard intercontinental ballistic missile fuel. So pentaborane could potentially be used as a rocket fuel if there are new issues with the turbopump, because again, when you combust borane, you will get particles of solid boron, and that could potentially damage the impeller in the turbopump. And so it may be necessary to have a small secondary fuel that provides the propulsion for the turbopump to pump the borane. Now, the borane and the oxidizer. Now, there are other kinds of boranes, and that's primarily diborane, but it is a gas, so it's really not very attractive. The energy density of this fuel is around 68 megajoules per kilogram. So that's about nearly 1.7 times higher than JP4 kerosene. The energy density by volume from the paper I read is 3 times higher. So per unit of volume, there's 3 times more energy. And I can provide sources for that in the video description. Now, as for the potential applications, again, I would imagine it is going to be primarily used as a rocket fuel, or in some specialized applications to burn it in the afterburner of a jet engine. Again, it will not really be operable in an internal combustion engine because of the production of this solid byproduct. Again, boron is a solid material. It's mined. It's in the earth, and you mine it, and there's about 1 billion tons of it. It's quite cheap. It's about $5 a kilogram. Now, pentaborane 9 is stable. Pentaborane 11 is unstable. So you're going to use pentaborane 9. Production and synthesis is simple and has already been. You can buy this chemical laboratory scale quantities, and so it has not been widely considered or studied as a rocket fuel. I would not really be able to tell you why that is, despite its high specific impulse and its very high energy density compared to even hydrazine. Hydrazine, it contains around 19 megajoules per kilogram. Again, pentaborane 9 is 68. So that's a huge difference. If you're going to be powering an intercontinental ballistic missile, that's a lot of weight saved, and that's as well as volume. The oxidizer, dioxide to fluoride, is it's quite volatile. It's quite dangerous, quite toxic, but it is stable. We could probably make a separate video on dioxide to fluoride. But again, it has been used, and the flame is green. Most people who have briefly studied borane rocket fuels will know that the flame is green, which makes it look quite cool. So applications are quite limited, and to very specialized applications that are going to be defense related, where the safety can be tolerated. Its LC50 is quite low. It's very dangerous stuff. But again, typically, great rocket fuels are not the safest chemicals. I mean, you think about hydrazine arguably one of the best rocket fuels because it's a liquid and it's hypergolic, and you can use N2O4, and it has a good specific impulse. And again, you can't really use a cryogenic fuel for an intercontinental ballistic missile because it has to be mission ready at all times. You can't exactly have boiling fuel in your tank, and the design of the tanks, design of the structure is easier when you're dealing with liquid fuels. The turbo pump, again, may be a little bit challenging because if you're going to use the exhaust energy to power the turbo pump, which is what you do, if you have a solid substance flowing into that turbo pump, that could cause issues with the bearings. That could, again, the same issue they found when using this as a jet engine fuel may be encountered when using it in the turbo pump. So I would not be able to tell you exactly how that would work out. I would imagine a secondary fuel would have to be used to power the turbo pump, and that would likely not compromise the energy density because the amount of power needed to pump the fuel is minimal. I mean, it's minimal compared to the total fuel payload, the total fuel load. But as far as the cost, again, boron is about $5 a kilogram, and the rest of the cost is going to be your H2 and the necessary multiple steps required for synthesis. And I will provide in the link papers to better understand and to better become more familiar with boron. Despite it's rarely studied, and there are almost no papers. If you go to Google Scholar and you put pentaborane fuel, all the papers are again from this 1960s program called ZIP fuel, also abbreviated high energy fuel, HEF. So yeah, it has limited applications, but in these specialized applications, it could be very attractive. And I would guess that it's going to be used, and I think quite successfully, as a hypersonic missile fuel. So these vehicles that are going to travel at Mach 5 are going to use a ramjet, and it could be air breathing. They're not going to carry an oxidizer and potentially carry warheads. Highly maneuverable as opposed to intercontinental ballistic missiles, which are essentially just rockets and are set on a fixed trajectory. Hypersonic missiles highly maneuverable because it is traveling at less than half the speed of a intercontinental ballistic missile. So I would imagine it's going to find a use when it's. I think it will be resurrected. I think it has too much potential. They could fuel with nearly twice the energy density of jet fuel cannot be ignored. And so I would imagine people becoming interested in this, possibly the Chinese, because the Western world has become kind of complacent. So I imagine if anybody's going to study this, it'll be China. So hopefully we'll see some interest in it. I definitely myself am interested in testing a hypersonic missile with this fuel. And if I ever get the money, I would definitely want to build a small prototype thrust vectoring hypersonic missile based on the Sears Hawk body. And using pentaborane 9 as a fuel. Again, pentaborane comes in 9 and 11. 11 is unstable and 9 is stable. So it's about 14% hydrogen by weight, and again, the properties I don't really have to go through as far as the melting point, boiling point, all that. So yeah, the density, again, it shows it's lower than jet fuel, but the energy density by volume is higher. Again, I would imagine it's got simply too much potential as a air vehicle fuel. So let's exclude aircraft, let's specialized air vehicles, high-speed supersonic air vehicles that are going to combust the fuel directly, not using a compressor. As an example, this aircraft that the British invented, I forgot the name. It's an aircraft engine that uses. My recording's going to stop, so then I pause right now. It uses a pre-cooler, and I don't think it has a compressor. It's sort of a ramjet, and they're going to use liquid hydrogen to provide the cooling, and also as a fuel. Again, these kinds of specialized air vehicles would greatly benefit from a higher energy dense fuel. So with that said, I think that's about all I can say. You can go through the synthesis process. I think it's quite simple. And again, you can purchase this. Is not a theoretical. This is not theoretical at all. This has been proven, and so it has a lot of potential if people become interested in it. And again, right now there aren't, because if you look at the papers published, the last papers published are from the 1960s. So it has been abandoned, and it could potentially be resurrected, a bit like thorium reactors. That's about all I have to say for today, and I hope you enjoy and start researching borane fuels.